So in this session, we will continue the discussion of topic moment. Just a quick revision. What is moment? Moment is refers to the turning effect of the force. When we apply a force and the object rotate, we call that as moment. And how it can be calculated? Moment can be calculated by using the force applied multiplied by the perpendicular distance from the point of rotation to the force, and it is a vector quantity because the turning effect can be a clockwise or it can be an anti-clockwise. And if object is equilibrium or object is balanced, in that case the total anti-clockwise moment balances with the clockwise moment. That was the last week discussion that we discussed about the concept of the moment and equilibrium. So in the first session, we will do questions related to moment, and in the second session, we will start a new topic, which is momentum. So in this question, figure 4.2 shows another elephant pushing horizontally against a vehicle with a force of 11 kilonewton. So 11 kilo means, because whenever we are using the units, it should be all in SI. So we have to convert this kilo into Newton, a normal. So what we should do whenever we are converting a kilonewton into Newton, we should multiply by 1000. So when we convert this 11 kilonewton into Newton, we have to multiply by 1000. So it will come out as 11,000 Newton. So force which is exerted by this elephant is actually 11,000 Newton. At a distance of 1.8 meter above the ground, and point M is the center of the mass. What is the meaning of center of the mass or center of the gravity? The center of the mass means it is the point where the weight of an object acts. So this car is having its weight, or weight of the car is acting downward. So the point where the weight of an object appear to act, that is known as the center of mass. In the first part, they're saying calculate the moment about point A. So whenever they give a reference to the point that about point A, so it means this point A is what? This point A is a pivot. Around this point, this object can rotate. So calculate the moment or turning effect about point A of the force exerted by the elephant. So when this elephant is trying to push this car can topple or rotate about this point. So which direction the car tend to rotate? Clockwise or anti-clockwise? If the elephant is applying force on the car and the car can rotate or turn around about point A, which direction it will rotate? Is it a clockwise direction or anti-clockwise? Because what will happen, like if I draw a figure, originally a car is like this, then the elephant is pushing the car. I'm not drawing the elephant. The car can topple or rotate about that point. So which direction this car will is rotating? So because it is opposite to the direction of the clock, so it will be anti-clockwise. So they're asking calculate the moment about point A of the force exerted by the elephant. So we want to calculate the moment, the turning effect caused by the elephant. So we know moment is equals to force multiplied by distance from the pivot, the perpendicular distance. So when we use the values, we know the force exerted by the elephant. So the force exerted by the elephant is 11 kilonewton or 11,000 Newton. And what about the distance from the pivot? Because A is a point of rotation, so perpendicular distance between the force and the pivot, that is 1.8. So when we calculate the moment, which is a product of force and distance. Force is given 11,000 Newton multiplied by distance is 1.8. What is the answer when 11,000 multiplied by 1.8? 11,000 multiplied by 1.8. So it will come out as 19,800 Newton meter. And what is the direction? That is anti-clockwise. Is it clear, the first part? Anyone having a doubt? To everyone? Look, in the first part, they're asking calculate the moment about point A or turning effect about point A of the force exerted by the elephant. So this elephant is exerting the force on the car, and what this elephant is trying to do, it is trying to topple the car. Like the car should, when elephant is applying the force, the elephant is actually trying to topple the car. So we have to calculate the turning effect caused by the elephant. The formula for turning effect or moment, that is force applied multiplied by distance. So what is the force applied by the elephant? It's given 11 kilonewton. So 11 kilonewton means 11,000 Newton, because to convert kilonewton into Newton, we multiplied by 1,000. So moment is a product of force into distance. The force which is applied by the elephant, that is 11,000 Newton, multiplied by distance. What distance we take? Here in the question, two distances are given. One is 1.25, another one is 1.8. So we always take a perpendicular distance, the distance which is perpendicular to the force. So if I take this distance, you can clearly see 1.8 is perpendicular or 90 degree to the force. But if I take 1.1, that is actually the parallel to the force, so that's why we are not taking that distance. So force multiplied by perpendicular distance. So force is 11,000 and perpendicular distance is 1.8. So our final answer will be 19,800 Newton meter. And which direction the elephant is trying to cause a moment? It is trying to cause a moment in anti-clockwise direction. So that was part one, in which we have to calculate the turning effect caused by this elephant. How anti-clockwise? Because if you check, if this is a clock and you can see if these are the hands of the clock, how they tend to rotate, they rotate in this manner. But when the elephant is applying a force, so elephant is trying to topple the car, is trying to flip the car. So if elephant is trying to flip the car, which direction the car is rotating? So it will rotate opposite to the direction of the clock hand. That's why we call that as anti-clock. The next part, the mass of the vehicle is 1,900 kilogram. Determine whether the elephant tipped the vehicle. So how we can determine whether the elephant tipped the vehicle? So basically there are two moments here. Number one, if this is a car, when the elephant, and this is point A, around which this car can flip. So when elephant is pushing the car, which direction the elephant is trying to cause a rotation? He's trying to cause a rotation in anti-clockwise direction. But what happens? There is also another force, that is the weight of the car, which is acting at the center. So if weight of the car is acting at the center, which direction the weight will try to cause a moment or turning effect? It will try to cause a moment or turning effect in clockwise direction. So weight is trying to cause a clockwise rotation and elephant is trying to cause an anti-clockwise rotation. So how we can identify whether elephant will cause a turning effect or elephant can flip this car? So for that purpose, we have to calculate both moments. We have to calculate the moment, the anti-clockwise moment due to elephant, and we have to calculate the clockwise moment due to weight of car. If elephant moment is higher, then the elephant can topple the car. But if moment due to weight is higher, then the elephant is not able to topple the car. So that's the main question, that we have to work out whether the elephant can topple this car. So we have to calculate both moments, the clockwise and anti-clockwise. If anti-clockwise moment caused by the elephant is higher, it can topple the car. If moment due to weight of the car is higher, then it will not, or the elephant cannot topple the car. So we'll solve this. The mass of the car is given in the question. The mass of the car is 1900 kilogram. That is the mass given in the question. So what will be the weight of this car? So how to get the weight of the car? Weight is mass multiplied by gravity. So mass is 1900 and gravity is 10. So the total weight of the car will be 19,000 Newton. And weight will act at the center. So weight is acting at the center. So this is the weight of the car, which is 19,000 Newton, and the weight is trying to cause a clockwise moment. Whereas elephant applying a force and it is trying to cause a anti-clockwise moment. So we'll calculate both of them. First, we'll calculate the anti-clockwise moment. So anti-clockwise moment by the elephant, the formula for moment, that is force multiplied by distance. Elephant is applying 11 kilonewton or 11,000 Newton, and the distance from the pivot is 1.8. So 11,000 multiplied by 1.8, we got that as 19,800 Newton meter anti-clockwise. Then what we do, we will calculate the moment, the clockwise moment by the weight of car. So weight of the car is producing, weight is the force and it is producing a clockwise moment. So moment is calculated by force into distance. The force which the car is applying, that's the weight of the car, which is 19,000. And the distance, we always take a distance from the pivot. So distance between the weight of the car and the point of rotation is 1.25. So 19,000 multiplied by 1.25. That is equals to 23,750 Newton meter clockwise. So the moment produced by the elephant is only 19,800, but the moment produced by the weight is higher. Can this elephant topple the car? Yes or no? The moment, the turning effect produced by the elephant is smaller as compared to the turning effect produced by the weight. Can this elephant topple the car? So this because the elephant is not producing enough moment, that is why your answer will be no. This elephant cannot topple the car. Is it clear, this part, to everyone? Because in the question they're asking, can this elephant topple the car? So how we can work out whether elephant topple the car? So there are two moments. One is the moment produced by the elephant and one is the moment produced by the weight of the car. Because the weight of the car is producing a greater moment and elephant is producing a smaller moment. That's why this elephant is not able to topple this car. Moving on to another question, a similar question. This is a similar question what we discussed right now in the previous one that was about elephant. So in this question, figure 2.1 shows a uniform. When they say uniform, it means the center of the gravity will be there at the center. So it's a uniform regular slab ABCD. The slab has a height of 0.8, so it is having a height of 0.8 and it's having a width of 0.3. And the mass of the slab is 18 kilogram. A force of 40 Newton is applied. On the figure, draw and label an arrow to show the weight. So how to label an arrow? We'll take a center of the object and we'll draw an arrow to show the weight. And what will be the weight of this object? Because if the mass is 18 kg, how to convert the mass into weight? We have the formula, weight is mass multiplied by gravity. So mass is 18 and the gravity is 10. So the weight of this object will be 180 Newton. So this is 180 Newton. The second part, calculate the moment of 40 Newton force about point D. So when they're saying about point D, so which point is a pivot? This point is a pivot. So whenever we are calculating a moment, to calculate a moment, that is force multiplied by perpendicular distance from the pivot. So we have the force of 40. But what about the perpendicular distance? So when I take the perpendicular distance between the force, so this is a total force, and here's the perpendicular 90-degree distance from the pivot. So force is 40 and the perpendicular distance is 0.6. So it will be 40 multiplied by 0.6, which is equals to 24 Newton meter. And which direction this will try to cause a moment? Which direction this will cause a moment? Clockwise or anti-clockwise? A force of 40 Newton. Which direction it will cause a moment? Turning effect. Yeah, that's right. It is anti-clockwise. So this is 24 Newton meter anti-clockwise. Is it clear, the first part? How to calculate a moment of 40 Newton force about point D. So from point D, we took a perpendicular distance between force and pivot. So that is 0.6 and 0.6 multiplied by 40. We got 24 Newton meter anti-clockwise. The next part, the moment of W about point D. So we want the moment of W about point D. So W is the force which is acting at the center. And how much is W? If mass is 18, the weight will be 180. So weight is 180 Newton. But what about the distance I should take? Because weight is acting at the center. So if the total length is 0.3 and the weight is acting at the center, So total, the weight is 180 Newton, which is acting at the center. So what is the distance from point D or about point D? So we always take a perpendicular distance. So what distance we'll take? Not the full distance 0.3, but the distance between the force and the point of rotation. Because it is a uniform object, so weight will act at the center. So if total length is 0.3, then half of it will be 0.15. So this distance will be 0.15. So when we calculate the moment or turning effect, that will be 0.3 multiplied by 0.15. That is equal, not 0.3, because the weight is 180. That is 180 the force multiplied by 0.15, which is equals to 27 Newton meter clockwise. And the moment due to this 40 Newton was 24 Newton meter anti-clockwise. So will this slab topple? Because the turning effect produced by 40 Newton meter, that is 20, the turning effect produced by 40 Newton force, that is equals to 24 Newton meter, and the turning effect produced by the weight is equals to 27 Newton meter. What will happen? This slab will topple, roll over, yes or no? So because the turning effect due to the weight is higher, so whenever the turning effect of weight is more, this object will not topple. Is it clear, this example? Any question or any doubt in this part? So it's a similar question that about the elephant, but instead of elephant, they just changed to a 40 Newton force. Then they're saying, state and explain what happened to the slab as a horizontal force is gradually increases. Like if we increase this horizontal force gradually, like here it is 40, then we are applying 41, then we are applying 42, then we are applying 43, 44, and so on. So what happened to this slab? If we are gradually increasing the clockwise moment due to the weight is 27 Newton meter. But when we are gradually increasing the value of this force, the anti-clockwise moment will increase, because the moment is a product of force into distance. So as we are increasing the force, the anti-clockwise moment will increase. As the anti-clockwise moment will increase, what will happen? The slab will topple. Is it clear, this part, that what happened when we gradually or slowly increase the force? So when we gradually or slowly increase the force, the anti-clockwise moment will increase. The anti-clockwise moment due to the horizontal force will increase, and it will topple. Okay, this question can have any answer, because they're asking, this question is related to equilibrium. Write down the name of 3 man-made devices in everyday use that depends on their action of moment of force. Like, can you name in some of the man-made devices which use turning effect of the force? Like, there's no fixed answer. You can name any of the device which you think use a turning effect. Like example, one of them I will write so that you have an idea. If I say spanner or a wrench, spanner uses a turning effect of the force. We apply the force and it rotates. That's good, Taha. Scissor, And what else? As you mentioned, door, that's also right. Even a stapler, you can, so any three you have to mention. Door you mentioned, door is also using the turning effect. We apply the force and it rotates. So these are wrench, spanner, scissor. These are man-made devices which use the turning effect of the force. Then the next part, figure 3.1 shows a uniform rod acted upon by three equal forces. Give two reasons why it is not in equilibrium. Look, when object is in equilibrium, there is no resultant force and there is no resultant moment. But they slightly change the question. They're saying why it is not in equilibrium. So if object is not in equilibrium, it means there is a resultant force and the second thing, there is a resultant turning effect, or you can say moment. Is it clear, this part? Because if these forces are equal in magnitude, if I say this is 10 Newton force, this is also 10 Newton, this one is also 10. So 10 Newton and 10 Newton, two are acting down and one of the 10 Newton is acting up. So what will be the resultant force? The resultant force will be 10 Newton downward. So there is a resultant force and this object can rotate. So there is a resultant moment or turning effect. That's why this is not in equilibrium. Another question related to the equilibrium. Figure 3.2 shows a uniform rod. When they say it is a uniform, it means they do not mention the weight, but you have to draw an arrow to show the weight. So if it's a 1 meter long, the weight will act at the center. A force of 12 Newton at a distance of 0.3. So this force of 12 Newton at a distance of 0.3, which direction it will cause a moment? Clockwise or anti-clockwise? Which direction it is causing a moment, turning effect, a force of 12 Newton? That is anti-clockwise. And a spring will try to pull it down with a force F. Which direction it will try to cause a moment? Clockwise. And if object is balanced, because they mention it is, they give you the hint here, it is held horizontal position, or it means it is balanced. So when object is balanced, the anti-clockwise moment is equals to clockwise. So anti-clockwise moment, the force is 12, the distance, that is 0.3. And the other force we don't know, that is F. And what about the distance? Because it's half of 1, which is equals to 0.5. So this will be 0.5. 0.5 is multiplied, other side it will divide. So 12 into 0.3 divided by 0.5, you will get the force which is applied by the spring. That's equal to 7.2 newtons. And why we did not consider the weight, or why knowing the weight is not important? Because it is acting at the center, so it will not cause any turning effect or a moment. Another question related to turning effect. Figure 3.1 shows a diagram of an arm holding a weight of 120 Newton. So arm is holding a weight of 120 Newton. A force of 20 Newton is a weight of the arm. So weight of the arm is there. And P is the point about which arm can pivot. So what is the point of rotation? P is the point of rotation, or P is the pivot. By taking the moment about P, so we have to take point P as a pivot, calculate F. So if we want to calculate F, dimension the arm, the diagram shows an arm with the hand holding the weight. So it is holding the weight, means it is balanced. So when an object is balanced, the total anti-clockwise moment will be equal to the clockwise moment. So which direction this 20 Newton will cause a rotation? Which direction the 20 Newton, the weight of the arm, cause a rotation? Clockwise. Which direction 120 Newton will cause a rotation? That is also clockwise. And both are the weight of the arm and the weight of the load, both are causing a clockwise rotation. And the muscles applying an upward force, so which direction muscles are trying to cause a rotation for the arm? That is anti-clockwise. And because the arm is balanced, so anti-clockwise moment is equals to clockwise moment. So the total anti-clockwise moment, the force of the arm is F multiplied by distance from the pivot. The distance between this force and the pivot, that's 2. So F into 2 equals the clockwise moment caused by 20 Newton. So 20 is a force multiplied by distance from the pivot, that is given 15, plus, because there is also another moment clockwise, that is 120 Newton force, and the distance of 120 Newton force is 33. Is it clear till this point? That the clockwise moment equal to anti-clockwise moment. So anti-clockwise moment is because of the force of the arm, and clockwise moment is due to the weight of the arm and weight of the load. So both are balanced. Now we just simply solve to get the answer. 20 multiplied by 15, that's equal to 300, plus 12 multiplied by 33, sorry, 120 multiplied by 33, that's equal to 3960. So 3960 plus 300, which is 4260. This 2 is multiplied, other side it will divide. So 4260 divided by 2, that's equal to 2130 Newton, because it's a force, so it is Newton, not Newton meters. Is it clear? So then they're asking the force act on the forearm. So which direction the force should be there to make it balance? Because if object is in equilibrium, the total upward force equal to total downward force, if object is in equilibrium or balance. The total downward force, this is 120 and 20, and this one is 2160, I think it was. So this was 2160. So because the arm must be balanced, the upward force is 2160. The one of the downward force is 20. Another downward force is 120. If I want to balance the arm, like this black line is representing the arm, So if I want to balance the arm, which direction there should be another force to balance it? Upward or downward? A force of 2160 is up. A force of 20 Newton is down and 120 is down. So which direction there should be a force from the pivot? Upward or downward? To make it balance. We want the resultant to be 0. Yeah, that's right, Abdullah. It should be downward because the upward force is higher. So upward force is higher, so the pivot should apply a downward force to make it balance. So the total upward force is 2160 and the total downward force is 20 plus 120 plus P. So 2160 and this is 140 plus P. This 140 will move other side. I think it was 2100 and that value was 20 multiplied by 15 plus 120 multiplied by 33 divided by 2. Yeah, that was 2130. So this is 2130. So when I move 140 other side, 2130 minus 140, that's equal to 1990 Newton. So they're asking which direction the pivot should apply a force to balance this arm. So the value of the force should be 1990 and the direction should be downward. Is it clear, this example? The direction of force exerted by the pivot to make the arm balance. So these are the questions related to topic the moment or the turning effect. No, we are not. Why we are adding it, Abdullah? Because you can see the upward force must equal to the downward force. The upward force, this is 2130. The downward force is 20 and 120. So the pivot should apply also a downward force to make it balance. So it is 2130, 20 and 120 are in the same direction. That's why we are adding with P. So on the downward side, we have 3 forces and upward side, we have only 1 force. So 2130, 140 plus P. So 140 move to other side, 2130 minus 140. So we'll get as 1990 newtons. So these are the questions related to moment. Now we'll start new topic which is about momentum. I'll share another link and continue this discussion.